So organic compounds which contains carbon and hydrogens are called hydrocarbons. కర్బన పదార్థాలు హైడ్రోజన్ మరియు కార్బన్ కలిగిన పదార్థాలను హైడ్రోకార్బన్స్ అంటారు. Hydrocarbons are classified into mainly three types. One is saturated hydrocarbons, unsaturated hydrocarbons, and the next one is aromatic hydrocarbons. హైడ్రోకార్బన్లను మూడు రకాలుగా విభజించడం జరిగినది. సంతృప్త హైడ్రోకార్బన్లు, అసంతృప్త హైడ్రోకార్బన్లు, నెక్స్ట్ అరోమేటిక్ హైడ్రోకార్బన్లు. సాచురేటెడ్ హైడ్రోకార్బన్స్, దీస్ ఆర్ ది హైడ్రోకార్బన్స్ విచ్ కంటైన్స్ ఓన్లీ సింగిల్ బాండ్స్. సో అన్సాచురేటెడ్ హైడ్రోకార్బన్స్, అసంతృప్త హైడ్రోకార్బన్లు, దీనిలో పై బంధాలు ఉంటాయి. దట్ మీన్స్ దీస్ కంటైన్స్ పై బాండ్స్. దట్ మీన్స్ దీస్ ఆర్ సింప్లీ ఆల్కీన్స్ అండ్ ఆల్కైన్స్. And aromatic hydrocarbons, these are nothing but that is hydrobenzene. These are aromatic hydrocarbons. Now today we are going to discuss regarding saturated hydrocarbons. In these saturated hydrocarbons, now we are going to focus mainly on alkanes. So we are going to discuss regarding alkanes. So these alkanes are also nothing but paraffins. Para means little. Affins means reactivity. Little reactivity or less reactivity. So paraffins are saturated hydrocarbons. So these having less reactivity. సో వీటి యొక్క చర్యాత్మకత చాలా తక్కువగా ఉంటుంది కాబట్టి వీటిని పారాఫిన్లు అంటారు. ఇందులో కార్బన్ మధ్యలో సిగ్మా బాండ్ ఉంటుంది. ఇందులో CH3 ఒక ఎగ్జాంపుల్, ఒక ఉదాహరణ తీసుకుంటే, ఇఫ్ యు టేక్ వన్ ఎగ్జాంపుల్ ఈథేన్, ఇన్ కార్బన్ దెర్ ఈజ్ నో పొలారిటీ. కార్బన్ మధ్యలో ఎలాంటి పొలారిటీ లేదు కాబట్టి వీటి యొక్క చర్యాత్మకత తక్కువగా ఉంటుంది. Not only methane, not only ethane, not only propane, so many alkanes, the reactivity is less, therefore these are called paraffins. So in these paraffins, now we are going to discuss that is methods of preparation of these paraffins. How these alkanes are prepared, so that we need here for all entrance examination point of view. So that is preparation methods are methods of preparation of alkanes. ఆల్కేన్స్ తయారీ విధానాలు. ఆల్కేన్స్ను మనం ఏ విధంగా తయారు చేస్తాము? దీనిలో మొదటగా ఫ్రమ్ ఆల్కీన్స్ అండ్ ఆల్కైన్స్. ఆల్కీన్స్ మరియు ఆల్కైన్స్ నుండి ఆల్కేన్లను తయారు చేయాలి. ఆల్కీన్స్ అంటే దీనిలో డబల్ బాండ్ ఉంటుంది, ఆల్కైన్స్ అంటే ట్రిపుల్ బాండ్ ఉంటుంది. సో హియర్ ఇన్ దిస్ వన్, దట్ ఈస్ ఆల్కీన్స్ ఆర్ ఆల్కైన్స్. దీస్ ఆర్ పాస్డ్ త్రూ నికెల్ ఆర్ ప్లాటినం ఆర్ palladium by passing through hydrogen. Alkenes or alkynes, when these are treated with hydrogen gas is passed through alkenes and alkynes, and hydrogen, these are passed through nickel or platinum. So these alkenes and alkynes are converted into alkanes. Here the total mixture, it is heated some temperature. సో ఆల్కీనులను, ఆల్కైన్లను మరియు హైడ్రోజన్ గ్యాస్ మిశ్రమాన్ని నికెల్ లేదా ప్లాటినం లేదా పెలాడియం ద్వారా పంపిస్తూ వేడి చేయగా మనకు ఏమొస్తాయి? ఆల్కేన్స్ వస్తాయి. ఇందులో ఎగ్జాంపుల్స్ తీసుకుందాం. దిస్ ఈజ్ ఏ హైడ్రోజినేషన్ రియాక్షన్. సపోజ్ ఇఫ్ యు టేక్ CH3CH double bond CH2. Propene anta. This is a propene. When this propene is treated with hydrogen gas in the presence of nickel or platinum or palladium, what happens here? Addition of hydrogen takes place. That is, alkene and hydrogen both are adsorbed on nickel or platinum and palladium sulfates. So that is, hydrogenation takes place. So we get here, this is very simple technique, H and H, here hydrogen is added here and here hydrogen is added here and the pi bond is eliminated. That means this is, it is addition reaction. Here we get CH3, CH2, CH3. This is a propane. Here propene is converted into propane. That means here unsaturated compound is converted into saturated compound. This is a addition reaction. So next, suppose if we take alkyne CH3, C triple bond C, CH3. This is butane. This is butane, 2-butane. This 2-butane, so when this 2-butane, when it is subjected to hydrogenation, so that is H2. Here also simple reaction, just we have to add this hydrogen. So one carbon and one more hydrogen, one more carbon. First of all, alkyne is converted into alkene, then alkene is converted into alkane. So first of all, so here this is converted into nickel or platinum or palladium. We can use nickel or platinum or palladium, any, so that is any metal, not all metals, that means nickel or platinum or palladium. Here hydrogenation takes place. Here we need, that is 2 moles of hydrogen. So first of all, alkyne is converted into alkene, then alkene is converted into alkane, that is CH3, CH2, CH2, CH3. This is a butane. Very simple. Here alkenes and alkynes easily converted into alkanes by passing through hydrogen, nickel or platinum or palladium surface. So suppose if we use only nickel, that reaction is called 𝗧𝗏𝗺 reaction. That reaction is called 𝗧𝗏𝗺 reaction. Okay. Sir, in this one, so we need one more important point, that is regarding stereochemistry. So that is for all entrance examination point of view, NEET and all other entrance examination point of view. So here that stereochemistry, so we can apply one rule, that is Carr rule. Sir, what is Carr rule? Carr rule means here Carr, TAM, TSR and CSM. So this is one rule. Now I will explain totally what is Carr rule. Here Carr, TAM, TSR, CSM. The first letter indicates, structure of alkene. Next, second letter indicates type of addition. And the third letter indicates type of product formed. Here C for, this is C for cis compound, T for trans compound, and A for, this is regarding reactants, and A for anti-addition, and that is S for syn addition, Next one, that is regarding third letter, R for racemic mixture, and M for mesocompound. So this rule is only for alkenes, not for alkynes. Alkenes, this is only for alkenes. This rule is only for alkenes. And here one more point here. Sir, where we can apply this rule? We can apply this rule. So reagent and alkene must be symmetrical. So I will give the examples also. First of all, here once again, alkanes are also called paraffins. These are little affinity and preparation methods, tayari paddhatulu. From alkenes and alkenes are alkynes when it is passed through nickel or platinum or palladium. by passing hydrogen gas we get alkanes. So example propene, this is a alkene, propene is converted into propane, and 2-butane is converted into butane. Next, sir, here we need important is stereochemistry, that is examination point of view. We can apply CAR rule. Sir, what is CAR rule? CAR, TAM, TSR, CSM. The first letter indicates regarding structure of alkane, the second letter indicates regarding type of addition, third letter indicates type of product formed. Here, this is C is nothing but cis compound, T is nothing but trans compound, and A is nothing but anti-addition, S is nothing but syn addition, R is nothing but racemic mixture, M is nothing but meso compound, and that is regarding. So here the condition is, in this one condition is, here the condition is that is reagent and alkene must be symmetrical. Okay, right. Next, let us discuss some examples. By using that CAR rule, now we are applying examples. Now we are playing on some examples. See here, CH3C, here C4H9, here double bond, here C4H9, here it is CH3. So this compound we can write in cis form and trans form. Sir, how? This is C4H9, C double bond, C4H9, here this is CH3, this is CH3. It is a cis compound. Why? Because C4H9 and C4H9 both similar groups are present at the same side of the double bond. This is a cis compound. Similarly, C double bond C, here this is C4H9, here C4H9, here this is a trans compound. This is a trans compound. Why? Because take CH3CH3 or C4H9. Here similar groups are if it present at the same side of the double bond, that is called cis. If the similar groups are present at the opposite side of the double bond, that is called trans. Here C4H9 same side, therefore cis. Here C4H9 opposite side, therefore this is a trans. ఇక్కడ CAR రూల్ను అప్లై చేసి మనము ప్రోడక్ట్స్ని రాయాలి. ఇది సిస్ కాంపౌండ్, ఇది ట్రాన్స్ కాంపౌండ్. సిస్ కాంపౌండ్ అంటే ఏంటంటే C4H9 సేమ్ గ్రూప్స్, ఒకే రకమైన గ్రూప్స్, డబల్ బాండ్ ఒకవైపు ఉంటే దాన్ని సిస్ అంటాము. ఒకే రకమైన గ్రూప్స్ ఆ డబల్ బాండ్కి ఆపోజిట్గా ఉంటే దాన్ని ట్రాన్స్ అంటాము. ఇది ట్రాన్స్, ఇది సిస్. నౌ హైడ్రోజినేషన్, హియర్ H2 addition of hydrogen, it is a syn addition. సిన్ అడిషన్ అంటే ఒకే వైపు నుంచి యాడ్ కావడం అన్నట్టు. Now this is a cis compound. Now hydrogen in the presence of nickel or platinum on heating. This is a syn addition. Similarly H2 syn addition in the presence of platinum. Now this is a cis compound, syn addition. Now we have that rule, that is CAR, TAM, TSR, CSM. Now we can apply that rule. Cis compound, syn addition. Yes, cis compound, syn addition. This is the structure of reactant, and this is the regarding type of addition. This is cis compound and syn addition. What we get beta? Meso compound. This is meso compound we get here. So very simple. We can write that like this. This is C4H9. Here also C4H9. Here we have CH3. This is also CH3 and HH. This is a meso compound. Now you have one doubt. Sir, what is meso compound? Meso compound is optically inactive. Sir, meso compound is optically inactive. Sir, actually what is the required condition for meso compound? Here it is chiral carbon, this is also chiral carbon. Along with chiral carbon, it is having plane of symmetry. Chiral carbon lo to paatu molecule lo chiral carbon to paatu plane of symmetry ఒకవేళ ఉంటే అది ఆప్టికల్ ఇన్యాక్టివ్, దట్ ఈస్ ఎ మెసో కాంపౌండ్. నెక్స్ట్ ట్రాన్స్ కాంపౌండ్ syn addition and racemic mixture. This is a trans compound and syn addition racemic mixture. So racemic mixture, what is racemic mixture? Equimolar mixture of dextro and levo. This is, here it is CH3, here it is CH3, this is H, this is H. So we get its mirror image plus, that is H, here it is CH3, here it is CH3, this is H, this is C4H9, here also C4H9. So this is nothing but racemic mixture. Both are enantiomers. Enantiomers are nothing but non-superimposable mirror images. So here we got racemic mixture. Okay. Trans compound syn addition, and we got racemic mixture. Racemic mixture is nothing but equimolar mixture of dextro and levo. Equimolar mixture of dextro and levo. So this is what this is, preparation of alkanes from alkenes and alkynes. This is finished. One more example in this topic, that means from alkenes. So that is entrance point of view, mainly entrance point of view. For example, we have, this is a alkene. Okay. Now I am treating with hydrogen in the presence of nickel. Sir, now the question is, how many products formed in this reaction? The question is, how many products formed in this reaction? Now we are adding hydrogen. What happens here? Hydrogen, hydrogen. One hydrogen is added here, one more hydrogen is added here. This is addition reaction, and pi bond undergoes cleavage. Here we get this compound. In this one, here we have only one. Here also we got only one. Here it is not a chiral carbon. Why? Because CH3 is same groups. This is not a chiral carbon. Right. Suppose if we take this example. Okay. Yes, otherwise we can write. Okay. Okay. And one more example. This is one compound, this is one compound. Here this is passed through hydrogen in the presence of nickel on heating. Here also hydrogen in the presence of nickel. So what happens? Here also addition of hydrogen takes place. Here also addition of hydrogen takes place. So here this we got this compound. In this one we got this compound. Yeah, this is an extraordinary example, simple example and beautiful example. So here if you observe this one, in the reaction, initially reactant is not having chiral carbon, whereas in product it is having chiral carbon. So what is chiral carbon? Chiral carbon ante carbon anedi 4 different groups nu attach ayi unte danni chiral carbon antam. Idi chudandi ikkada. So idi chiral carbon kaadu. Endukante 1 2 3 4 1 2 3 4. Let us take one more carbon here. Right. One more carbon. Now see here. 1 2 3 4 5. 1 2 3 4 5. Here this is ethyl group, this is propyl group, this is methyl group, and it is having one more hydrogen. So this is a chiral carbon. That means here chiral carbon, how many products are formed? 2 power n, that is n equal to 1, that is 2 power 1, that equal to 2. Here 2 products are formed, one is dextro, another one is levo. So whereas here in this one, if you observe this one, this is hydrogen. You have 1 2 3 4 5, 1 2 3 4 5. Now if you observe this one, this is ethyl and this is also ethyl, and this is also ethyl. This is not a chiral carbon, this is not a chiral compound, this is optically inactive, and it is a chiral molecule, That means, so here we got only one product, here we got 2 products, in this one we got 1 product. This is a chiral, which one? This is a chiral molecule, and this is a achiral molecule, and this is also a chiral molecule. So questions mainly based on chiral and achiral and number of compounds formed. So this is okay. This is preparation of alkanes from alkanes. It is finished. We can prepare alkanes from alkyl halides. So this is the second method from alkyl halides. ఆల్కైల్ హాలైడ్ల నుండి ఆల్కేన్స్ను తయారు చేయడం. అసలు ఆల్కైల్ హాలైడ్స్ అంటే ఏంటి? RX, these are called alkyl halides. R is nothing but alkyl group. Alkyl group is nothing but that may be methyl or ethyl, any alkyl group. Here X is nothing but that may be halogen, that is chlorine or bromine or iodine. Alkyl halides, we are converting alkyl halides into alkane. For this conversion, we have different methods. So that is the first method. This is Łusz reaction. The second method is this is Core-House synthesis. Third one is Frank-Land reaction. And this is Grignard's reaction. Grignard's reaction, and E is, this is a reduction. In this mainly, so this is important and this is also important, and so somewhat this one is also important for all entrance examination point of view. Now we are going to discuss regarding Woods reaction. It is very, very important reaction. Woods reaction. So Woods reaction is nothing but, so here it is having 5-star rating. So this is Woods reaction. So Woods reaction is nothing but alkyl halides. When these are treated with sodium dry ether. When alkyl halides are treated with sodium in the presence of dry ether, we get alkanes. Alkanes having double the number of carbon atoms. Woods reaction is nothing but mainly used for the preparation of alkanes. Woods reaction is nothing but alkyl halides when it is treated with sodium in the presence of dry ether, that is converted into alkanes having twice the number of carbon atoms. Here in this alkyl halides, see, let us discuss some examples. Suppose if you take CH3Cl or CH3Br, this is a methyl chloride. This methyl chloride, when it is treated with sodium dry ether, we get what beta? This is, here we get CH3 plus 2NaCl. This is, we got here, this is ethane. ఆల్కైల్ హాలైడ్లను సోడియం లోహముతో డ్రై ఈథర్లో వేడి చేయగా ఆల్కేన్స్ వస్తాయి. ఇందులో డబల్ ది నెంబర్ ఆఫ్ కార్బన్ ఐటమ్స్ ఆఫ్ ఆల్కేన్స్ వస్తాయి. ఒక కార్బన్ ఉన్న ఆల్కైల్ హాలైడ్ తీసుకుంటే 2 కార్బన్లు ఉన్న ఆల్కేన్ వస్తుంది. 2 కార్బన్లు ఉన్న ఆల్కైల్ హాలైడ్ తీసుకుంటే 4 కార్బన్లు ఉన్న ఆల్కేన్ ఫామ్ అవుతుంది. సపోజ్ ఇక్కడ మిథైల్ క్లోరైడ్ తీసుకుంటే ఈథేన్ వచ్చింది. సింపుల్గా షార్ట్ కట్ రాయడానికి, సో ఇది మెకానిజం కాదు, సింపుల్ CH3Cl, దట్ ఈస్ 2Na ప్లస్ Cl CH3. ఇక్కడ ఇలా రిమూవ్ చేసేయాలి, మిగతా పార్ట్ని యాడ్ చేసేయండి అంతే. CH3 ప్లస్ 2NaCl. దీనికి మెకానిజం ఏంటంటే, దీనికి అయానిక్ మెకానిజం ఉంది, అదేవిధంగా నెక్స్ట్ ఫ్రీ రాడికల్ మెకానిజం కూడా కలదు. సో ఇన్ దిస్ వన్, so this is methyl chloride is converted into ethane. Suppose if we take ethyl chloride, CH3CH2Cl, this is ethyl chloride. Ethyl chloride nu sodium dry ether to react cheyega, sodium dry ether. Here we get that is butane. This is N-butane plus NaCl. Let us discuss that mechanism. Free radical mechanism. In this one, that is sodium is a metal, sodium loses electrons. Okay. In this one, sodium is a metal, sodium loses electron and its form sodium plus ion, and that is a cation is formed and this is electron. Now this is CH2, here this is a Cl, this is ethyl chloride. Now we are concentrating that is ethyl chloride molecule. How ethyl chloride is converted into butane? Now the sodium loses electron. The electron, so which is from sodium, that electron attacks here, and this is Cl is eliminated in the form of Cl minus. Here in this we get, this is CH2 free radical plus Cl minus. Next one, that is CH2 free radical, and combines with one more CH3 free radical. That means in this reaction we have so many free radicals. Now we are not in single molecules. Actually we are heating the solution by taking 1 liter or 2 liters. That means 1 mole contains 6.023 into 10 to the power of 23 molecules. So many molecules are present. That means so many ethyl free radicals are formed. So here so many possibilities. One ethyl free radical combines with one more ethyl free radical. Yeah, what happens here? Dimerization takes place. Yeah, this is a dimerization. And here we get CH3, CH2, CH3. Yes, this is butane. And here one more possibility. In this one, according to not only dimerization, we have one more possibility, that is CH3CH2 free radical. This is CH3CH2 free radical. This ethyl free radical, that is CH2H, this one undergoes homolytic cleavage, and here this hydrogen free radical migrates from here to here, now here to here. So we get what beta, this is CH2. Here again it is free radical is produced. This free radical merge with each other and forms double bond, and this H free radical combines with the CH3CH2. We get that is CH3CH3. So that is a dimerization reaction. This is a disproportionation reaction. Disproportionation reaction. Disproportionation reaction. This is ethylene is formed and ethane is formed. That is a butane. That is a dimerization reaction, and this is a disproportionation reaction. That means the major product is butane and the minor product is ethylene and ethane in examination. So which product is not formed in the reaction? అలాంటి క్వశ్చన్స్ అడిగే అవకాశం ఉంటుంది. ఒకవేళ ఇథైల్ క్లోరైడ్ సోడియం డ్రై ఈథర్లో జరపగా మనకు 3 ప్రోడక్ట్స్ వస్తాయి. ఒకటి బ్యూటేన్ వస్తుంది, ఒకటి ఎథిలీన్ వస్తుంది, ఒకటి ఈథేన్ వస్తుంది. ఇందులో మనకు ఆల్కీన్ కూడా ఫామ్ అవుతుంది. అదేవిధంగా ఆల్కేన్ ఇక్కడ మనకు బ్యూటేన్ రావాలి, బ్యూటేన్తో పాటు ఈథేన్ కూడా వస్తుంది, రైట్. సో దిస్ ఈజ్ వన్ ఎగ్జాంపుల్ ఇథైల్ క్లోరైడ్. నౌ దట్ ఈస్ లిమిటేషన్స్ ఆఫ్ Woods reaction. By this method we can't prepare methane. మీథేన్ను ప్రిపేర్ చేయలేము. మీథేన్లో ఒకే కార్బన్ ఉంది. ఒకే కార్బన్ ఉన్న ఆల్కేన్ ప్రిపేర్ చేయాలంటే సగం కార్బన్ అనేది ఉండదు. కాబట్టి మీథేన్ను ఈ చర్య ద్వారా మనం ప్రిపేర్ చేయలేము. నెక్స్ట్ టెరిషరీ ఆల్కైల్ హాలైడ్స్. టెరిషరీ ఆల్కైల్ హాలైడ్స్ cannot be used in this method. If we use tertiary alkyl halide, it do not gives alkane, it gives alkene. It gives alkene instead of alkane. Here we get that is alkene. And third one, sir, why we are using dry ether? Why we are not using that is wet ether or moist ether? What happens if we use some moist ether or wet ether? Suppose if we use, let us consider we are using wet ether. What happens? That wet means it contains water, moisture. This water reacts with sodium and it is converted into sodium hydroxide and hydrogen gas is liberated. Therefore, that means here sodium loses its activity. So therefore, here sodium metal, it is a metal, it easily catches fire when reacts with water. Suppose, so therefore sodium cannot be stored in water. సోడియంను వాటర్లో స్టోర్ చేయరు. జనరల్గా దేనైనా వాటర్లో స్టోర్ చేస్తారు, కానీ సోడియంను వాటర్లో స్టోర్ చేయరు. సోడియంను వాటర్లో స్టోర్ చేస్తే అది వాటర్తో రియాక్ట్ అయ్యి మొత్తం అది ఇట్ క్యాచెస్ ఈజీలీ ఫైర్స్ అండ్ ఎక్స్ప్లోజన్ టేక్స్ ప్లేస్. దేర్ఫోర్ ఇన్ దిస్ వన్, so actually we need sodium for why? Because when we need electrons, suppose if we use water, what happens? Sodium reacts with water and it forms sodium hydroxide. So this is the required condition. So we should not use that is wet ether, we should use better that is dry ether. This is the limitation of which reaction, that is Woods reaction. In this Woods reaction, so one more important point here in examination point of view, entrance point of view. Suppose X is a alkyl halide, it is treated with sodium dry ether. Sir, here we got this product. This is nothing but 1, 2, 3, 4, 2, 3 dimethyl, 2, 3 dimethyl butane. Now our question is, so what is X? How can we write X from this product? Very simple. So it is symmetrical or unsymmetrical? It is 100% symmetrical. So just break this molecule like this. Take this part and take that part and add here halogen. Here also add halogen. That means you add that is halogen. Let us take iodine. So this here, this is the product. That means this is a isopropyl iodide. This is a isopropyl iodide. This isopropyl iodide, when it is subjected to sodium dry ether, here we get 2, 3 dimethyl butane. So next, in this one we have one more, that is crossed Woods reaction. That means if you take different types of alkyl halides, suppose you take methyl chloride, Sir, ethyl chloride. Sir, what is the product possible in this reaction? Sodium triether. Very simple. In methyl chloride and ethyl chloride, this is methyl free radical is formed, there ethyl free radical is formed. In the reaction mixture, we have so many methyl free radicals and also ethyl free radicals. Here we have possibilities. Methyl free radical may merge with methyl free radical, we get ethane. Similarly, ethyl free radical may merge with ethyl free radical, we get butane. And methyl free radical may combines with ethyl free radical, we get propane. Mainly 3 types of alkanes are formed. Other products are also formed, that is disproportionation reaction. The main products are that is 𝗧𝗦𝗔𝗧 reaction. Actually, this method is not suitable or otherwise not suggestible for the preparation of alkanes having odd number of carbon atoms. అంటే ఆల్కేన్లో ఆడ్ నెంబర్ ఆఫ్ కార్బన్ ఆటమ్స్ ఉన్న ఆల్కేన్ను ప్రిపేర్ చేయడానికి ఈ మెథడ్ అనేది సజెస్టబుల్ కాదు. సార్ నాకు ప్రోపేన్ కావాలి అంటే నీకు ప్రోపేన్ కాదు, ఈథేన్ వస్తుంది, బ్యూటేన్ వస్తుంది, ప్రోపేన్ వస్తుంది. కాబట్టి ఇక్కడ 3 కాంపౌండ్స్ వస్తున్నాయి కాబట్టి సపరేట్ చేయడం చాలా కష్టము. కాబట్టి ఇది పర్ఫెక్ట్ మెథడ్ కాదు. దేనికి? ఆల్కేన్స్ హ్యావింగ్ ఆడ్ నెంబర్ ఆఫ్ కార్బన్ ఆటమ్స్. నెక్స్ట్ వన్, దిస్ ఈజ్ బి రియాక్షన్. దిస్ ఈజ్ ఏ 𝗳𝗏 సింథసిస్. 𝗳𝗏 synthesis. Sir, 𝗳𝗏 synthesis ఏంటి? This is the best method for the preparation of all types of alkanes. There is no restriction. By this method, we can prepare alkanes having odd number of carbon atoms or alkanes having even number of carbon atoms. In the previous case, in the Woods reaction, that is not a suggestible process for the preparation of alkanes having odd number of carbon atoms. But this method we can prepare all types of alkanes. Here is no restriction. So therefore, this is the best method for the preparation of alkanes from alkyl halide. Here in this one, that is primary or secondary or tertiary alkyl halides. Primary or secondary or tertiary alkyl halides. These are treated with, first of all, lithium. This is converted into alkyl lithium. This is converted into alkyl lithium. This alkyl lithium, it is treated with CuI. What is CuI? That is called cuprous iodide. This cuprous iodide, it is converted into, that is dialkyl lithium cuprate, that is R2CuLi. Here we get this is RLi. Rx is converted into RLi. That RLi plus CuI, we get here, this is R2CuLi. This is nothing but dialkyl lithium cuprate. This is called Gilman's reagent. Gilman's reagent. This Gilman's reagent, it is treated with again alkyl halide. So what is this alkyl halide? This alkyl halide, this alkyl halide, same or different? That may be same or that may be different. So here this is converted into alkane. This is converted into alkane. Right. So 𝗳𝗏 synthesis, this is used for the preparation of alkanes from alkyl halides, that is primary or secondary or tertiary alkyl halide. It is treated with lithium. Here we get alkyl lithium. That alkyl lithium, it is treated with CuI. This is converted into dialkyl lithium cuprate, or that is nothing but Gilman's reagent. So this Gilman's reagent, it is treated with Rx. This alkyl halide, this alkyl, both may be same or different, and here we get this is alkane. Sir, suppose if we take methyl iodide plus lithium, here we get CH3Li. Now this CH3Li, now it is treated with CuI. Here we get CH3 taken twice CuLi. Now this CH3CH is taken twice CuLi. Now in this reaction, this is called Gilman's reagent. This is dimethyl lithium cuprate. Sir, I want propane. Naku propane kavali sir. Propane kavalante already ikkada methyl group undi. Manaku kavalsindi ethyl group. Therefore, here we are taking, this is ethyl iodide. Ethyl iodide. So just take this methyl group and take this ethyl group. Ethyl and add methyl, you will get what beta? This is CH3, CH2, CH3. This is a propane is formed. So only one product is formed. In the previous case, we got so many products. This is what this is 𝗳𝗏 synthesis. So this 𝗳𝗏 synthesis, it is finished. The next one is, that is Grignard's reaction. So this is C, this is Grignard's reaction. Grignard's reaction. Sir, Grignard's reaction, here we need RMgX. or MgX is called Grignard's reagent. So Grignard's reagent is nothing but alkyl magnesium halide. This alkyl magnesium halide is called Grignard's reagent. So this Grignard's reagent, by using this Grignard's reagent, we can prepare different types of alkanes. This is also a beautiful question. So this is also a beautiful topic. So Grignard's reagent. So how Grignard's reagent is prepared? When alkyl halide, when it is treated with the magnesium in the presence of dry ether, here we get RMgX. ఆల్కేన్స్ ప్రిపేర్ చేయడానికి ఇదొక మెథడ్, గ్రిగ్నార్డ్స్ మెథడ్. గ్రిగ్నార్డ్స్ మెథడ్లో గ్రిగ్నార్డ్స్ రియేజెంట్ అనేది గ్రిగ్నార్డ్స్ అనే సైంటిస్టు దీన్ని తయారు చేశాడు. RMgX ఆల్కైల్ మెగ్నీషియం హాలైడ్ను గ్రిగ్నార్డ్స్ రియేజెంట్ అంటారు. ఈ ఆల్కైల్ హాలైడ్ను మెగ్నీషియంతో డ్రై ఈథర్లో చర్య జరపగా మనకేమొస్తుంది? ఆల్కైల్ మెగ్నీషియం హాలైడ్ వస్తుంది. ఈ ఆల్కైల్ మెగ్నీషియం హాలైడ్, ఇందులో ఆల్కైల్ గ్రూప్ అనేది ఇది R- యాక్ట్ చేస్తుంది. R- అంటే ఇది న్యూక్లియోఫైల్, అదేవిధంగా స్ట్రాంగ్ బేస్ అంటే ఇది బలమైన క్షారము, అదేవిధంగా న్యూక్లియోఫైల్. R-. Now this is treated with active hydrogen containing compound. అంటే యాక్టివ్ హైడ్రోజన్ ఉన్న పదార్థాలతో చర్య జరపగా మనకేమొస్తుంది? ఆల్కేన్ వస్తుంది. RH ప్లస్ MgOHX. ఠీక్ హై. నౌ సపోజ్ ఒక ఎగ్జాంపుల్ తీసుకుందాం. CH3CH2MgI. సార్ దీన్ని ఇథైల్ మెగ్నీషియం అయోడైడ్, దీన్ని ఎలా ప్రిపేర్ చేస్తాము? దిస్ ఈస్ ప్రిపేర్డ్ ఫ్రమ్ CH3CH2I magnesium in the presence of dry ether. So what we got here? Ethyl magnesium iodide. This ethyl magnesium iodide, in this one, this is CH3CH2 minus, this is ethyl. Ethyl is a nucleophile as well as a strong base. This ethyl magnesium iodide, now it is treated with active hydrogen containing compound. Sir, ఒకవేళ మనము వాటర్తో రియాక్ట్ చేస్తే ఏమవుతుంది? వాటర్లో H ఉంది, ఆ H అనేది యాక్టివ్ హైడ్రోజన్, దీంతో రియాక్ట్ ఏమవుతుంది? ఇందులో CH3CH2 మైనస్, అందులో H, దట్ వి గెట్ హియర్ CH3CH3. డోంట్ కాన్సన్ట్రేట్ ఆన్ బై ప్రోడక్ట్ సార్. హియర్ ద బై ప్రోడక్ట్ ఈస్ MgOHI. యాక్చువల్లీ వీ నీడ్ hero, not side hero, that is hero is ethane. Okay, so that is ethyl magnesium iodide, it is on reacting with water we get ethane. Similarly, sir, if it is treated with D2O, so what happens? D2O here, it is having deuterium, this is ethyl and deuterium, we get that is CH3CH2D plus MgODI. ठीक है sir. If we treat with alcohol, you take any alcohol. Suppose let us take methyl alcohol. This methyl alcohol, it is having active hydrogen. This active hydrogen reacts with this one, and here we get CH3 plus CH3OMgI. Next, sir, if it is treated with phenol, yes, very good. This phenol is also compound. In this phenol also active hydrogen is present. This ethyl and hydrogen, here we get this is ethane, and plus this is this is OMgI. Next, sir, if it is treated with carboxylic acid, yes, carboxylic acid, it is also having acidic hydrogen. Acidic hydrogen or active hydrogen similarly same. So this acidic hydrogen, now this hydrogen reacts with this ethyl, and here we get again ethane. The byproduct is this is CH3C+OMgI. And similarly, this ethyl magnesium iodide, that is CH3CH2MgI. Sir, if it is treated with MgI, if it is treated with suppose sulfuric acids, you take sulfuric acid, that is CH3R. If it is treated with R, S double bond OH. Again, it is having also acidic nature. So we get here this is CH3. Similarly, if it is treated with RNH2, or NH2. Here it is also having hydrogen. So therefore this is CH3. Similarly, if it is treated with secondary amine or NHR, this is a primary amine, this is a secondary amine, this is a secondary amine. Again it is having active hydrogen or acidic hydrogen. Here we get that is CH3. Right. Sir, if we treat with, this is a beautiful example. Right. Actually, everybody is thinking it is not having active hydrogen, but it is having. So here this is active hydrogen. How you are saying it is active hydrogen? Suppose here this is CH3CH2 minus. You subtract this H plus, that means it loses electrons, and here we get what? This is the product is formed. So this is negative charge. Negative charge 2 plus 2 4 plus 2 6 electrons. 6 pi electrons. 6 pi electrons means aromatic. That means these hydrogens easily eliminated in the form of H plus. We got aromatic compound, more stable compound is formed. This is a cyclopentadiene is converted into cyclopentadienyl anion. This cyclopentadienyl anion, it is a aromatic. Therefore, this hydrogen is also easily replaced by, that is CH3CH2 minus. So here in this one we get which product? This we get, this is CH3CH3. These two are important. Okay. So this is regarding Grignard's reaction. So this Grignard's reaction also completed. And also, so alkyl halides can be converted into alkanes by using reduction, that is reduction of alkyl halides. Alkyl halides can be reduced to alkanes by using some special reducing agents. This is D. So this is by reduction of alkyl halides. Here we have some reducing agents, that is first of all metal acids. So the metal acids are zinc plus HCl, or zinc acetic acid, or zinc ethyl alcohol, etc. These are metal acids. These metal acids, suppose alkyl halide, when these are treated with metal acid, if it is treated with metal acid, here we get alkane. Second one, by using metal hydrides. In these metal hydrides, so that is lithium aluminum hydride AlH4, and also sodium borohydride NaBH4, and also that is PH3SNH triphenyl tin hydride. This is also called TPH. TPH is nothing but triphenyl tin hydride. So this lithium aluminum hydride, it is giving H minus. Sodium borohydride, it is also giving hydride H minus, and triphenyl tin hydride is also giving H minus. Not only this one, we have that is tributyl tin hydride, Bu3SNH. This is nothing but TBH. Tri-N-butyl tin hydride. These we can use. All these are producing H minus. Lithium aluminum hydride, sodium borohydride, triphenyl tin hydride, that is TPH, and TBH, tri-N-butyl tin hydride. ఆల్కైల్ హాలైడ్లను రిడక్షన్ అంటే క్షయకరణం చేయగా మనకు ఆల్కేన్స్ వస్తాయి. ఇందులో మెటల్ ఆమ్లాలను ఉపయోగించవచ్చు. ఆల్కైల్ హాలైడ్లను జింక్ HClతో కానీ, జింక్ ఎసిటిక్ యాసిడ్ ACOH అంటే ఎసిటిక్ యాసిడ్, లేదా జింక్ ఇది జింక్ ప్లస్ ఇథైల్ ఆల్కహాల్, దీంతో చర్య జరపగా ఆల్కైల్ హాలైడ్ అనేది ఆల్కేన్గా మారిపోతుంది. అదేవిధంగా మెటల్ హైడ్రైడ్లను కూడా ఉపయోగించి ఆల్కైల్ హాలైడ్లను ఆల్కేన్గా మార్చవచ్చు. ఇందులో లిథియం అల్యూమినియం హైడ్రైడ్, దిస్ ఈజ్ సోడియం బోరోహైడ్రైడ్, అండ్ దిస్ ఈజ్ ట్రైఫినైల్ టిన్ హైడ్రైడ్, అండ్ దట్ ఈజ్ ట్రై-N-butyl టిన్ హైడ్రైడ్. ఇందులో లిథియం అల్యూమినియం హైడ్రైడ్ని యూజ్ చేసినప్పుడు ప్రైమరీ అండ్ సెకండరీ ఆల్కైల్ హాలైడ్స్, ప్రైమరీ మరియు సెకండరీ ఆల్కైల్ హాలైడ్స్, దట్ ఈస్ ప్రైమరీ ఆల్కైల్ హాలైడ్స్ అండ్ సెకండరీ ఆల్కైల్ హాలైడ్స్, this primary alkyl halide and secondary alkyl halides both converted into alkanes. Both can be converted into alkanes. ఒకవేళ ఇందులో ఇది ఇంపార్టెంట్ పాయింట్ ఏంటంటే, ఇందులో టెరిషరీ ఆల్కైల్ హాలైడ్లను తీసుకుంటే లిథియం అల్యూమినియం హైడ్రైడ్తో రియాక్ట్ చేయగా ఇందులో ఆల్కీన్ ఫామ్ అవుతుంది, ఆల్కేన్ ఫామ్ కాదు. చాలా ఇంపార్టెంట్ ఇది. ఓన్లీ లిథియం అల్యూమినియం హైడ్రైడ్ అనేది ప్రైమరీ ఆల్కైల్ హాలైడ్ను సెకండరీ ఆల్కైల్ హాలైడ్ను ఆల్కేన్గా మార్చవచ్చు, కానీ టెరిషరీ ఆల్కైల్ హాలైడ్లతో రియాక్ట్ చేస్తే ఆల్కీన్స్ వస్తాయి. రైట్. సోడియం బోరోహైడ్రైడ్, ఇందులో స్పెషాలిటీ ఏంటంటే ప్రైమరీ ఆల్కైల్ హాలైడ్ అనేది ఆల్కేన్గా మారదు. ఇందులో మాత్రం సెకండరీ అండ్ టెరిషరీ ఆల్కైల్ హాలైడ్స్, సెకండరీ అండ్ టెరిషరీ ఆల్కైల్ హాలైడ్, సో బోత్ కెన్ బి కన్వర్టెడ్ ఇంటూ ఆల్కేన్స్. కానీ టీపీహెచ్, ఇది ఫస్ట్ తీసుకుందాం, ఇది ఏ అనుకుందాం, ఇది బి అనుకుందాం, ఇది సి అనుకుందాం, ఇది డి అనుకుందాం. ఏలో మనకు ఒక ఆటంకం ఉంది, ఏంటంటే టెరిషరీ ఆల్కైల్ హాలైడ్ ఆల్కిన్గా మారిపోతుంది. సోడియం బోరైడ్లో మనకు ఒక డ్రాబ్యాక్ ఉంది, దట్ ఈస్ ప్రైమరీ ఆల్కైల్ హాలైడ్స్ ఆర్ నాట్ కన్వర్టెడ్ ఇంటూ ఆల్కేన్స్. అదేవిధంగా సపోజ్ ట్రైఫినైల్ టిన్ హైడ్రైడ్, అదేవిధంగా ట్రై ఎన్బ్యూటైల్ టిన్ హైడ్రైడ్, ఈ రెండు రెడ్యూసింగ్ ఏజెంట్లను తీసుకుంటే ఇందులో ప్రాబ్లం ఏమీ లేదు. ఇందులో దట్ ఈస్ దట్ ఈస్ టీపీహెచ్ అండ్ టీబీహెచ్, టీపీహెచ్ అండ్ టీబీహెచ్ బోత్ కన్వర్ట్స్ ప్రైమరీ ఆర్ సెకండరీ ఆర్ tertiary alkyl halides. Tertiary alkyl halides are converted into alkanes. Tertiary alkyl halides are converted into alkanes. So this is preparation of alkanes from alkyl halides by reduction. These methods are important. Okay. So after this one, next one, that is after by reduction. Next here we have coal base electrolysis. Coal base electrolysis, that is from carboxylic acids and derivatives. So this is from carboxylic acids. This is third one, from carboxylic acids or otherwise salts of carboxylic acids. From salts of carboxylic acids. Salts of carboxylic acids. Here we have again two methods. One is soda lime decarboxylation. Soda lime decarboxylation. In soda lime decarboxylation, that is here we are using soda lime. Soda lime is nothing but the mixture of NaOH plus CaO. This is called soda lime. So that is salts of sodium carboxylic acid or carboxylic acids or otherwise salts of carboxylic acids. Carboxylic acids or salts of carboxylic acids. When these are heated with soda lime, NaOH plus CaO, this is called soda lime. Decarboxylation means loss of CO2. D means loss. CO2, carboxylation means loss of CO2. This is decarboxylation. Carboxylic acid or salts of carboxylic acid, when it is heated with soda lime, we get alkanes. కార్బాక్సిలిక్ ఆమ్లాలను లేదా కార్బాక్సిలిక్ ఆమ్లాల యొక్క లవణాలను సోడా లైమ్తో కలిపి వేడి చేయగా మనకేమవుతుందంటే డికార్బాక్సిలేషన్, అంటే CO2 అనేది ఎలిమినేట్ అయ్యి మనకు ఆల్కేన్స్ ఫామ్ అవుతాయి. ఇందులో ఎగ్జాంపుల్ CH3CH2COONA. If it is treated with soda lime, NaOH and CaO on heating, so what happens? This one is eliminated. This means carbon dioxide is eliminated in the form of sodium carbonate. The remaining one is this is CH3, CH2 and H. Here we get CH3 plus Na2CO3. This is ethane. This is sodium propionate. In this one important point here, 1, 2, 3. If we are taking carboxylic acid with n number carbon containing carboxylic acid, if it is subjected to soda lime decarboxylation, we get alkane having, that is 2 number of carbon atoms, that is n minus 1. If you take n is converted into n minus 1 carbon. This is soda lime decarboxylation. And B1 is coal base electrolysis. In coal base electrolysis, that is salts of carboxylic acids. Aqueous solution is subjected to electrolysis. We get alkanes or alkenes or alkynes. And cycloalkanes are also produced in this reaction. The specialty of this reaction, coal-based electrolysis, is used for the preparation of alkanes, alkenes and also alkynes. चलो ठीक है, अभी एग्जाम्पल्स डिस्कस करेंगे इसमें. नाउ इसमें अभी चलो CH3COONA, दिस इज कॉल्ड सोडियम एसीटेट. Sodium acetate, when it is subjected to aqueous solution of sodium acetate, when it is subjected to electrolysis, here we get ethane, CH3 plus 2 moles of NaOH plus hydrogen gas, and also CO2 is also liberated. In this one, see here, CH3 C double bond O Na, CH3 C double bond O Na plus here HOH, here also HOH. In this one, this is NaOH and NaOH, and here it is CO2 and this is also CO2, and hydrogen gas is liberated. The remaining just migrate like this bond, you will get this is CH3 plus 2 moles of CO2 plus 2 moles of NaOH plus hydrogen gas. So that means if we take sodium acetate, we get here it is alkane is producing. This is alkane is formed, alkane. Right. So in this one we got alkane. Sir, I want alkene. Yes, we can also prepare alkene here in this one. Suppose if you take sodium succinate, similarly same coal-based electrolysis, HOH, yeah, electrolysis. In this one, NaOH and NaOH, it is CO2 and hydrogen gas is liberated, and this bond is migrated, CH2 double bond CH2, this is ethylene is formed, plus 2 moles of CO2 plus 2 moles of NaOH plus hydrogen gas is liberated. Actually, in this reaction, not only these products formed and other products are also formed. Mainly, we are concentrating alkanes and alkenes. Sir, if we take CH double bond CH, this is COONA. Now COONA. So far we are prepared, that is alkenes. Now we are preparing, this is what this is. We are preparing now, that is alkynes. The concentration is preparation of alkynes. Again, removes the same NaOH, CO2 and hydrogen, and this bond is migrated. Here we get CH triple bond CH plus 2 moles of CO2 plus NaOH, 2 moles of NaOH plus hydrogen gas. This is called, actually this is a sodium fumarate or sodium maleate. Sodium fumarate or sodium maleate, it gives alkyne acetylene. Coal-based electrolysis, coal-based విద్యుత్ విశ్లేషణము, ఇది ఆల్కేన్స్ను ప్రిపేర్ చేయడానికి, ఆల్కీన్స్ను ప్రిపేర్ చేయడానికి, ఆల్కైన్స్ను ప్రిపేర్ చేయడానికి, సైక్లో కాంపౌండ్స్ను కూడా ప్రిపేర్ చేయడానికి ఉపయోగించవచ్చు. ఒకవేళ మనం సోడియం ఎసిటేట్ తీసుకుంటే ఈథేన్ వస్తుంది, సోడియం సక్సినేట్ తీసుకుంటే ఎథిలిన్ వస్తుంది, సోడియం ఫ్యూమరేట్ కానీ సోడియం మెలియేట్ని కానీ తీసుకుంటే ఎసిటైలిన్ వస్తుంది. దిస్ ఈజ్ సోడా లైమ్ డికార్బాక్సిలేషన్, దిస్ ఈజ్ కోల్ బేస్డ్ ఎలక్ట్రాలిసిస్. So here this is the preparation methods of alkanes, and here and one more method, that is preparation of alkanes and by using a special reagent that is called 𝗳𝗏 red phosphorus, 𝗳𝗏 red phosphorus. So this is fourth one, and this is 𝗳𝗏 by using 𝗳𝗏 red phosphorus, by using HI plus red phosphorus. By using HI red phosphorus, we can prepare alkanes. So this is a fantastic reagent and a beautiful reagent. So that is for the conversion of all types of compounds, not all types of compounds, that is oxygen containing compounds. HI red phosphorus అనేది ఒక రెడ్యూసింగ్ ఏజెంట్. ఏంటంటే ఆక్సిజన్ ఉన్న పదార్థాలను HI red phosphorusతో క్షేకరణం చేయగా మనకు ఆల్కేన్స్ ఫామ్ అవుతాయి. ఏంటంటే చూద్దాం. ఫర్ ఎగ్జాంపుల్ ఆల్కహాల్స్ తీసుకున్నాం. Alcohols, CH3CH2OH, this is alcohol. You take aldehyde, CH3C double bond OH, This is acetaldehyde. Or you take ketone, that is acetone, CH3 double bond O CH3. This is acetone. Similarly, ఒకవేళ carboxylic acid, yes, CH3COOH. This is acetic acid. అదేవిధంగా anhydrides, అదేవిధంగా అమైడ్స్, అదేవిధంగా యాసిడ్ క్లోరైడ్స్. వీటిలో ఏ పదార్థ అయినా తీసుకొని యూ టేక్ ఎనీ కాంపౌండ్ ఆర్ when these are treated with HI red phosphorus, we get alkanes. That means in this one we get ethane, in this one again we get ethane, in this one we get propane, in this one we get ethane. HI red phosphorus, it is mainly used for the conversion of alcohols into alkanes and aldehydes into alkanes and ketones into alkanes and also carboxylic acids into alkanes.